I'm going to give you a demonstration of 3 user interfaces that have been developed with the Sassafras User Interface Development System, and show you a little bit of the runtime environment of Sassafras. Sassafras is a prototype of a powerful user interface development system. It was explicitly designed to support the rapid development of user interfaces that make use of multiple input devices and concurrent dialogues. It has been implemented in InterLISP-D and runs on Xerox 1100 series workstations. This is a Xerox 1109. The environment includes a large format display, a keyboard, and a mouse. We have added this touch-sensitive tablet. When a finger is pressing on this black surface, this device reports where on the surface the finger is touching. The 3 interfaces that I'm going to show you are a paint program that can be controlled with 2 hands at the same time, an extension of the furniture positioning in a room program described in Chapter 2 of Fundamentals of Interactive Computer Graphics by Foley and Van Dam, and the user interface that controls the Sassafras runtime environment. I will start by showing you a simple paint program. I come down to the Sassafras control panel and bring up a menu of user interfaces to start. I select the paint program. A new row is added to the Sassafras control panel, and I'm prompted to create a window for the paint program. I'm now ready to start painting. I press down the mouse button and hold to paint and release when I'm finished. Each time I click on the +1 menu item, the brush is made 1 notch larger. Similarly, each time I press on the -1 menu item, the brush is made smaller. I can also directly select a size for the brush by clicking on the size item and then selecting a brush size from the menu I'm presented with. I can change the color to a mid-gray and a light gray, and I can also change the mode of painting. I will now erase with the gray brush. So far, I have done everything with my right hand. My left hand has been totally useless. I can use my left hand on the touch tablet to control the size of the brush and the color of the paint. Imagine that the left 2/3 of the touch tablet is laid out the same as the left 2 columns of this menu. So if I press at the top, I can get black ink, the middle to get gray ink, and the bottom to get light gray. Similarly, I can change the mode of painting as well. Now, to control the size of the brush, imagine that the right edge of the touch tablet behaves as a one-dimensional mouse. So I can reduce the size of the brush by touching the tablet and stroking down, and I can increase by stroking up. I can do that as a sequence of strokes. Now what I can do is paint and change the size of the brush at the same time. So I'm going to slowly reduce the size of the brush, and now bring it back up again, and change the color again, change to erase, reduce the size of the brush. I've just drawn a continuous stroke of varying size and color. This would be very difficult to do with any existing paint program, but it is easy with this one. This is because the user is free to use one hand to control the size and the color, and the other to control the position. Sassafras encourages the development of concurrent user interfaces like this one. Now I'm going to show you the most advanced in this series of 4 user interfaces that began with the furniture positioning in a room program described in Chapter 2 of Fundamentals of Interactive Computer Graphics by Foley and Van Dam. I positioned a chair, a desk, and a divider in this room. Now I'm going to position another divider down the side of the desk here. To do that, I will select it and rotate it as I'm bringing it across, and then position it. I have elaborate control over the rotations that I can do with this program. So I'll move this chair over to show you some of the things I can do. I can do jump rotations to the key positions. I can also do arbitrary rotations. For rotation in this interface, the touch tablet is used to implement 3 different virtual devices. The primary virtual device is a 3x3 matrix of buttons. So there are 9 buttons in a regular grid. If I press on the center button on any edge, the chair is rotated to face in that direction. So pressing center left rotates to face left, pressing center top rotates to face top. This is how I do jump rotations to the key positions. If I press in the corner buttons, I get the second virtual device. This is an absolute rotation device, so if I press in the lower right, the chair rotates to face lower right. If I press upper right, the chair rotates to face upper right. If I press and hold and then drag, the chair follows my finger and points in the direction of my finger. When I release, the touch tablet now behaves as a matrix of buttons again. So this is how I get arbitrary rotations. Finally, the last virtual device is a very sensitive slider. To access it, I press in the middle and then slide down to reduce rotation and press and slide up to increase rotation. With this, I can achieve very precise rotations. For example, if I want to rotate the chair to 35 degrees, I slide up just a little bit to get one more degree, 35 degrees. Now I can rotate and position the chair to make it look a little more natural, to make it look a little more like my office. This interface demonstrates a task that can clearly be performed faster through the use of concurrency. By allowing the user to both position and rotate at the same time, the furniture can be positioned more quickly than if the two had to be done sequentially. Also, this interface demonstrates that Sassafras can be used to fully exploit the capabilities of the touch tablet. This results in an interface that allows common rotations to be quickly achieved, but still allows arbitrary rotations. Now I'm going to show you a little bit of the Sassafras Runtime Environment. This is a Sassafras control panel. It was implemented with Sassafras. It is a menu-based interface. Clicking on virtually any button has some meaning. If I click on the Paint button here, the name of the Paint program is brought to the top and all the input devices are given to it. Similarly, if I click on Layout 4, the Layout program, the Room Layout program, is brought to the top and it is given all the input devices. If I click on Layout Floor with both buttons at the same time, I'm given a menu of commands that I can apply to that user interface. I will select Edit, and I'm given a list of modules that I can edit. I will select the main module for that user interface. Execution of that user interface has been suspended while I'm editing it, and I can now make some changes to this user interface. I don't really want to make any changes right now, so I will exit from the editor. The specification is checked for any syntax errors, and none are found. And now I can resume execution of the program from exactly the point where I suspended execution for editing, but now running the changed specification. The control panel interface demonstrates that Sassafras can be used to generate menu-based interfaces to realistic applications. It also demonstrates that the concurrency and communication features of Sassafras can be used even if there is no obvious concurrency in the user interface. In this case, there are two concurrent dialogues, one between the user and the user interface, and another between the user interface and the application. This is a natural and obvious structure, but it is not supported by any existing user interface development system. In conclusion, Sassafras is a fully functional prototype of a powerful user interface development system. It encourages the use of multiple input devices and cooperation between the user interface and the application routines. More importantly, it supports the rapid refinement and development of user interfaces. These features have been illustrated with 3 user interfaces that have been developed with Sassafras.